So we've reached the point in this chapter, in this level, where we had to start talking about story problems and real-world applications. So the first story problems that we talk about deal with exponential functions, and we're going to be talking all about compound interest. So this section, this level, 5.7, deals mostly with money problems. And before we talk about compound interest, we're going to be talking about simple interest. So if you plan on ever getting a credit card or a car loan or a home loan, or if someone gives you money that you want to invest in, this is one of those relevant chapters that you will actually see in your real life. So let's jump into it. Simple interest. So if a principal P dollars, which means starting off point. So principal always means starting out amount, is borrowed for a period of T years per annum, which means per year, at a per annum interest rate, per yearly interest rate R, expressed as a decimal, then the interest charged is I equals P times R times T, where I is the interest, P is the principal amount, R is the rate, and T is the amount of years. Now this is called simple interest because we don't have any complex factors. We're only talking about yearly, we're talking about a simple rate, and we're talking about a dollar amount. So things that I need you to know. If you see in a story problem it says annually, that means one time a year. Semi-annually means 2 times a year. Quarterly is 4 times a year because there's 4 quarters. Monthly, there are 12 months. So this happens 12 times per year. And daily would be 365 times in a year. Okay. So once we have that, just using this simple interest formula, we're going to try some of these problems out. So a credit union pays interest of 8% per annum, per year, compounded quarterly on a certain savings plan. If $1,000 is deposited in such a plan and the interest is left to accumulate, how much is in the account after 1 year? So this is the key thing that we need to find out is it says it's compounded quarterly, which means this is going to happen 4 times a year. So what we're going to do is we're going to have to do this 4 times. So we start off with, let's say we're looking for I. We know the rate, which is 8%. So we're going to write that as 0.08. T is quarterly, so 1/4 of a year, because our simple interest rate is in years, or 0.25. And then our principal is $1,000. So the formula that we use is I equals P times R times T. So the interest that we make after the first quarter is 1,000 times 0.08 times 0.25. So I'm just going to take my calculator out, make a new document. No, we don't want to save. Add a calculator. So 1,000 times 0.08 times 0.25. We hit enter, we get $20. So the interest we made is $20. So that means your principal, let's say P of 0, is 1,000. So your principal now after 1/4 is $1,020. So what's the interest after 2 quarters? Well, we take our new principal, our new amount that we're starting with, times 0.08 times 0.25. Let's put parentheses around there so we understand that. So I can just hit enter and move this all the way over to the tens place. That's good. Now I've made $20.40. Okay, so my principal now after the second quarter is, we're going to add 2040. So 1040.4. Okay, so the interest after quarter three, you can see why this is a little more not as simple as if we just gave you something over a year. So we have 1040.4 times 0.08 times 0.25. So let me grab this and just change this to 40.4. So our interest was $20.80. And let's call that 81. So if after 3 quarters, we're at 1,060, 61 and 21 cents. So interest after 4 quarters is 1061.21 times 0.08 times 0.25 equals. So I'm going to change this one more time. So I'm going to go over to this. So this we wrote 61.21 times 0.08 times 0.25. And then we're going to add that to 1061.21. And we get 1082.43. So this was 21.2242. So our principal, or how much we made after 4 quarters, is $1,082.43. So after 4 quarters, compounded quarterly, we turned that simple money into $1,082, which is pretty nice. So the next formula that we're going to talk about is compound interest. So this takes into a couple more factors than just simple interest. So we talk about A is the amount after T years. P again is our starting off point. R is our interest rate. And N is the number of times compounded yearly. So our formula that we get is A equals P times 1 plus R over N to the NT. And this is what we're going to be using on the next page. Okay, so with example 2, let's just read this out. Investing $1,000 at an annual rate of 10%. So P is 1,000, R is 10%, which is 0.10. Compounded annually, semi-annually, quarterly, monthly, and daily will yield the following amounts after 1 year. So I'm first going to write out the formulas, and then I'm going to do it on the calculator. So let's say our first one, amount after annually. So I'm going to write 1 year. So we have 1,000 times 1 plus our rate. Remember, our formula is A equals P times 1 plus R over N to the NT. That's our exponential. So our rate is 0.1 over 1 to the 1 times 1, which looks a lot like our simple interest formula. Okay, so if I take my calculator, I'm just going to type 1,000 times, it's important to write that times, otherwise it'll give you an error, 1 plus, and I'm going to hit control division so I can easily change this, 0.1 over 1 to the 1 times 1. So if I do that at 10%, it makes sense. I'm just going to make $1,100. If I get compounded semi-annually, so I'm just going to write semi, same formula, 1,000, 1 plus 0.1 over 2 to the 2 times 1. So now we're getting something squared. Okay? So then I go to my formula, just hit enter to change that. I'm only going to change the n, which is 2, and I'm going to change this n to 2. The year still stays the same. If I hit enter, I made it $2 more compounded semi-annually, $2.50. So that's 11 Okay? If we just do quarterly, and I'm just going to speed this up for us, is 1,000, 1 plus 0.1 over 4 to the 4 times 1, which is, okay, $1,103.81. So we made a little bit more, $1,103.81. If we did it monthly, the amount we make if it's 12 times, so 1,000, 1 plus 0.1 over 12 to the 12 times 1. Okay, so now we're to the 12th power, so obviously it's going to be a little bit more than that. What? 12. Okay, so another dollar. And this is just off of $1,000. So $1,104.71. Okay, last one is daily. So 1,000, 1 plus 0.1 over 365 to the 365th times 1 year. And you can expect this to be quite a bigger number, especially if, let's say we did this after 2 years. That compound interest daily will get large very, very quickly. So again, 1105.15, let's say 1105.16 if we round up. And these are all dollar amounts. So if you had the option to choose, if you were investing money, you would see that if you had your interest compounded daily, that you would make the most money. Likewise, if you had invested your money and it's compounded yearly, then you're not making as much money. But if you're on the other side, let's say you're getting charged interest for money you borrowed, you would want a yearly compounding versus a daily. And what it turns out is that daily is pretty close to what the banks do for most credit cards. So here's an interesting thing. When interest is compounded so that the amount after 1 year is P times e to the RT, which is really close to what daily is, we say that the interest is compounded continuously. So that means instead of daily, we're talking about to the second. So continuously just means every time you think about the money, you're getting interest on it. So continuous compounding, or compound continuously, is another important thing, which is based around E. So here is our other formula, which is oftentimes called PERT, APERT. The amount after T years due to P invested at annual interest rate R is A equals PE to the RT, which takes you out of thinking about the number of times it's compounded. So let's read example 3. The amount A that results from investing a principal P of 1,000 at an annual rate of 10% compounded continuously for 1 year. So A equals PE to the RT. We want to know what A is. If we start off with 1,000, E to the R is 0.1 or 10%. So 0.1 times 1 year. So then we'll go to our calculator, make sure that it's on, and we'll do 1,000, then second, or we don't need second, E to the 0.1 times 1. And if you see, here we had daily, and here we have compounded continuously. These two numbers are pretty close, closely representing each other. So we could almost say daily is the same thing as compounding continuously. We're off by a cent if you compare these two. So here's what in a chart that you might see that takes an annual interest rate with how many times it's compounded to the effective simple interest rate. And this is oftentimes what you see on credit card charts or loan charts, is they'll say, oh, our interest rates are only 10%, but it's compounded monthly or it's compounded continuously. So really, when you do the math, it's really a lot higher. So I wanted to expose you guys to this to kind of see how the effective interest rate is equivalent to an annual simple interest rate that would yield the same thing as doing it compounded continuously. I know this is a lot of words, and this is like, wow, I didn't know we were in an accounting class, but sometimes math is relevant. So let's flip it over and do a couple more examples. Okay, so starting with example 4, it says on January 2nd, 2007, someone just placed $2,000 into an IRA, which is an individual retirement account. So then it says it will pay interest of 7% per annum compounded continuously. Okay, so when we see compounded continuously, that means we have our formula A equals PE to the RT. Okay, our R is 7% and P is $2,000. Okay, you had a generous aunt, uncle, grandma, grandpa, mom, dad. So they're just putting that money in for you. So what is the effective interest rate, effective annual interest rate? So if we did 1 year, e to the 0.07 times 1. So if we found out what A is, 2,000 times e to the 0.07, we get $2,145.02. I'm going to round. So our rate will be a little different. And I want to find out what my effective interest rate would be. So my effective interest rate, or my interest, so what is the interest that I made off of this? My interest is my annual minus my principal. So I made 2145.02 minus, I started with 2,000. So I made $1,045.02. So now I'm going to use I equals PRT, which if you remember from the first page, that is our simple interest rate formula. Now our principal was $2,000. Our interest that we made was $145.02. We're looking for R, and T is 1 in both of these cases. So we just take 145.02 divided by 2,000, and then we get our simple interest rate. So if we do that really quickly, 145.02 divided by 2,000, and then if we multiply that by 100 just to make it easier, we get 7.251%. So that's how you find the effective interest rate. So another type of problem that they might ask you about is, let's say, if I give you the amount that you start with, or sorry, the amount that you have today, how much should you have invested previously? So all this is doing is, if we had A equals P times 1 plus R over N to the NT, and we divide both sides by this quantity, it's really just multiplying by the negative exponent, which is what this formula is. Same thing here. If we just divide everything by e to the negative RT, or e to the RT, it's the same thing as multiplying by the negative exponent. So present value formulas are the exact same thing. We're just solving for P instead of A. So they give you these formulas, but if you want to just remember P equals E, A equals P E R T, or A equals P times 1 plus R over N to the NT, those would be just the same. Okay, so example 5. A zero coupon non-interest-bearing bond can be redeemed in 10 years for $1,000. How much should you be willing to pay for it now if you want to return at 8% monthly or 7% compounded continuously? Okay, so if you're going to get $1,000 in 10 years, so in 10 years, you're making $1,000. what should you buy it for? So 1 plus the rate, which we want to get, is 8%, so 0.08, compounded monthly, which is 12, to the 12 compounded, that's our n, times 10 years. So we could figure out what this is, or we could say this is 1,000 times 1 plus 0.08 over 12 to the negative 12 times 10 equals P. That's just dividing this quantity out. So if I type that in my calculator, I have 1,000 times, parentheses, 1 plus 0.08 divided by 12 to the negative 12 times 10. So if you want to make money on this, if you want to make 8% interest, you should buy this for $450.52. So your principal, in order to make that money in 10 years, should be $450.52. If we did it compounded continuously at 7%, we're saying 1,000 equals P e to the 0.07 times 10, or P equals 1,000 times e to the negative 0.07 times 10. So again, calculator, I want 1,000 times e to the negative 0.07 times 10. So compounded continuously, I want to buy that at, in order to make my interest rate that I want, $496.58. All right, flip it over and we have one more page. So talking about doubling money. So these are fun, doubling or tripling an investment. How long is it going to take you, or what do you have to invest? These are types of things that people want to think about, especially in retirement. They're like, okay, I want to save $20,000. So how much should I invest if I only get this? So let's see the question. What annual rate of interest, so I want to know what R is, compounded annually, should you seek if you want to double your investment in 5 years? Okay, so we have our compound interest, and let's say we start at a principal P, or let's say it's A. It doesn't matter. You could pick an amount, $10. So then in 5 years, so T equals 5, you want to have 2A, or 20. You doubled whatever principal that you started with. So let's go to our formula. A equals P times 1 plus R over N to the NT. And our N is 1 because it's compounded annually. So we know that we want to have 2 times the amount, and that's equal to the amount that we started with, plus 1 plus our rate, which is what we're looking for, over 1 to the 1 times 5. Okay, so first off, if we're solving for R, let's divide both sides by A. So we have 2 equals 1 plus R to the 5th power. Okay, so then how do we solve for R? We can do one of 2 things. We can take the log of both sides, which if we're doing, we can use properties of logs, or we can take the 5th root of this problem. So to solve this, we're just going to take the 5th root. So ignore this. I have 2 equals 1 plus R to the 5th. Take the 5th root of both sides. So we have the 5th root of 2 equals 1 plus R, subtract 1. So the 5th root of 2 equals, or minus 1, equals R. So I go to my calculator. Let's ignore the other work. We have, so my calculator, I can type this 5th root of 2, and then let's make sure we're outside, minus 1. And if we hit enter, and I'm going to hit control enter, we see that R is 0.14. I'm going to round up to 9, or 14.9%. So once we get to here, we don't have to do the logs. We can just take the fifth root and then solve. Let's see time required to double or triple an investment. So same type of question. How long will it take for an investment to double in value if it earns 5% compounded continuously? So this is important to figure out how long. If it says how long it will, we're asking for to find time. So to find time, we're going to look at this compounded continuously. So A equals P-E-R-T. So let's say principal is A, so then our amount would be 2A, because we're doubling. And our interest rate was 5%, or 0.05, so 0.05 to the t. So now our variable, what we're trying to find is the exponent, and this is what's going to require logs. So if we divide both sides by a, the a's cancel. So we have 2 equals e to the 0.05 t. Now we take the log of both sides. So we get, and we can move our exponent down now. So we have ln of 2 equals 0.05 t times the ln of e. Well, the ln of e is just 1. So we can just divide both sides by 0.05. So t equals the ln of 2 divided by 0.05. And if I have my calculator, which we do, ln of 2 divided by 0.05, and then hit enter, you see that we get 13.86 years. If we did B, how long will it take to triple? The only difference here is now we're going to say instead of 2 times A, or whatever our amount is, it's going to be 3 times A. So then the A still cancel. We still take the natural log. This still becomes 1. So we have the ln of 3 divided by 0.05 equals t, which would be, just quickly change this. The only thing that changes is the number we type in for our log. So knowing that, we get 21.97 years. Okay, hopefully this wasn't too confusing, and I think actually working through some of these problems, and this is going to help. And then we're going to use this to do some studying about credit cards.